Okay, let's start the lecture again. So, so we have seen that mu star of n decreases to 0. Then the limit is 0. We can choose an integer k. So choose an integer k. Choose an integer k. Choose an integer k, positive integer, such that mu star of ek is less than epsilon. Is mu star of ek less than epsilon? Okay, this we can do because limit of mu star of en is equal to 0. इसका लिमिट 0 है तो for each epsilon positive you can find some integer k. Okay, with this property. That's very simple. That's the definition of limit of a sequence of real numbers. Now if n is greater or equal to k, now if n is, let's choose any positive integer n which is greater or equal to k, then we see that then this holds. Then this holds for any n greater or equal to k. This phi kx, this thing, it is less than epsilon. Phi kx is less than epsilon. Why it's less than epsilon? It's less than epsilon for all x belongs to b minus ck. X belongs to b minus ek complement. Okay, because on ek phi kx is greater or equal to epsilon. ek की definition en को जो अभी आपने डिफाइन किया en. तो ek की डेफिनेशन क्या है? ek की डेफिनेशन ये है कि इसमें जो भी पॉइंट होगा वहां पर क्या होगा, phi kx होगा ग्रेटर और इक्वल टू एप्सिलॉन. अब क्योंकि x ek में नहीं है तो रिवर्स इनइक्वालिटी, strictly less than epsilon. Then we see that this thing 0, which is obviously less or equal to phi n because it's decreased to 0. So limit of phi n is 0. Phi n का लिमिट 0 है और ये डिक्रीजिंग फ्रीक्वेंसी. ओके, सो दैट मीन्स phi n इज ग्रेटर और इक्वल टू 0. कोई लिमिट डिक्रीजिंग फ्रीक्वेंसी है और इसका लिमिट अगर 0 है, डिक्रीजिंग फ्रीक्वेंसी है और लिमिट 0 है, सो इसका मतलब है कि हर कोई phi n जो होगा ना वो ग्रेटर और इक्वल टू 0 होगा. दैट्स ट्रिवियल because 0 is the infimum actually. So this phi n, it's greater or equal to 0, and phi n is less or equal to phi k. Why? Because n is greater or equal to k and phi n is a decreasing sequence. That means phi n must be less or equal to phi k. N is greater or equal to k, phi n is decreasing, which means that phi n is less or equal to phi k. So because your sequence phi n is decreasing, and that thing it's equal to phi k of characteristic function of ek into characteristic function of ek, sorry, it's ek here, characteristic function of ek plus phi k times characteristic function of ek complement, which is b minus ek. b minus ek, क्योंकि हम सिर्फ पॉजिटिव वैल्यू ले रहे हैं. पॉजिटिव वैल्यूज जब हम कंसंट्रेट करेंगे ना पॉजिटिव वैल्यूज पर, वहाँ पर सेट बी हमने ऑलरेडी डिफाइन किया है, जहाँ पर इस फंक्शन के सिर्फ पॉजिटिव वैल्यूज है, तो वो सेट बी है. तो हमारा जो होल सेट है वह द सेट ऑफ द पॉइंट where the images are positive, that's the set B. So that's why we are taking here phi k into chi of ek, then plus phi k and chi of b minus ek. You are taking the complement of ek in b only, not in whole x. So this gives, let's apply now integral by previous theorem. If phi is less or equal to psi, then integral of phi is less or equal to integral of psi. So by previous theorem, 0 is less or equal to integral of phi n, it's less or equal to integral of phi k, but this phi k, the upper bound of phi k is m, so this phi k is less or equal to m, it's less or equal to m times integral of chi of ek, that's its integral is mu star of ek, plus phi k on ek complement. On ek complement, here you can see phi k is less than epsilon, so it's less than epsilon, so you can write here strictly less, okay, should write here strictly less than epsilon, okay, this is strictly less than epsilon. अब मैं इसको 2-3 स्टेप्स को एक ही स्टेप में लिख रहा हूँ. This phi k is strictly less than epsilon, and then we have chi of b minus ek. It's obviously it's major mu star of this set, mu star of the set. It is mu star of b minus ek. Mu star of b minus ek. Okay. So I think this phi k chi b minus ek, this phi k is less or equal to epsilon times chi of b. Okay, chi of b. But mu star of b minus ek is less or equal to mu star of b. That is trivial. That is trivial. Okay, it's 0 less or equal to integral of phi n, which is less or equal to m times mu star of ek plus epsilon times that number. Okay. So this means 0, you have the 0 is less or equal to integral of phi n, that's less or equal to integral of phi k, उसके में जरूरत नहीं, it's less or equal to, or you can strictly less than m times mu star of ek plus epsilon times mu star of b minus ek, that's less than mu star of b, because b minus ek is b minus ek is subset of b by monotone property of outer measure. Now what's this mu star of ek? Mu star of ek क्या है? I think it's less than epsilon. Mu star of ek is less than epsilon. That's already chosen integer k such that mu star of ek is less than epsilon. So this thing it's less than epsilon times mu star of ek is less than epsilon. It's epsilon times m plus mu star of b for each epsilon positive. For each epsilon positive. And this is true for all n greater or equal to k. So that means the limit of the integral of phi n must be equal to 0. This means limit of integral of phi n must be equal to 0. So which implies that integral of phi n decreases to 0 because it's the decreasing limit. तो इसका सेकंड पार्ट दैट्स वेरी सिंपल. वहाँ पर आपको फंक्शंस दोनों ले ली है. यहाँ पर तो आपका ज़ीरो लिमिट था, वहाँ ज़ीरो लिमिट नहीं है. द सेकंड पार्ट, इसका सेकंड पार्ट ये है, दिस फाई एन इट इंक्रीजेस टू 5. ओके, फाई एन इंक्रीजेस टू 5. almost everywhere. This is given. Okay. So then phi minus phi n. Phi minus phi n. This gives phi minus phi n. Let's see this limit. What's phi? Phi as it's phi as it's okay. Phi as it is, but minus phi n, you can see minus phi n, it decreases to minus phi. Okay. अब यहाँ ये स्टेप ऐड कीजिए. This implies minus phi n, it will increase to minus phi. Okay. Multiplying throughout by minus 1. Okay. Minus phi n decrease to minus phi. Now what's this? Phi minus phi n. Phi as it's but minus phi n decrease to minus phi, so it decreases to phi minus phi. That's equal to 0 almost every time. Now we can apply the first part. It means that integral of phi minus phi n decreases to 0, but this gives integral of phi minus integral of phi n decreases to 0. Okay. That gives minus times integral of phi n decreases to minus integral of phi. Now let's again multiply throughout by minus 1. It gives integral of phi n increases to integral of phi. So that's the end of this theorem. Okay, next theorem. Assume we have two sequences of step functions, both have same limit. Then you have to show that limit of integral of the first sequence is same as the limit of the integral of the second step function. Let phi n and psi n be the sequence of step functions such that let phi n and psi n be sequences of step functions. Okay. Step functions. Sets phi. Both sequences. This satisfy this. Phi n, it increases to f. F is not a step function. Okay. And psi n increases to f almost everywhere. It's f. This f is a measurable function, where f is a given function, not a measurable. It's any function where f, it's any arbitrary function. F from x to r star. R star means extended real number system is a given function. Is a given function. Then we don't know, we cannot define integral of f. Okay, we don't have. आप ये नहीं कह सकते कि इंटीग्रल ऑफ फाई एन जो होगा इट विल कन्वर्ज टू इंटीग्रल ऑफ एफ एंड इंटीग्रल ऑफ साइन जो होगा वो भी कन्वर्ज करेगा इंटीग्रल ऑफ एफ को. सो दैट मीन्स द लिमिट ऑफ द इंटीग्रल्स आर सेम, बट दैट्स नॉट द केस बिकॉज एफ इज नॉट इंटीग्रल. वी कैन नॉट. हाँ, अगर एफ स्टेप फंक्शन होगी उस केस में ओबियसली इक्वल था. अगर फाई एन भी इंक्रीज करे फाई को, साइन भी इंक्रीज करे फाई को, देन वी कैन अप्लाई द प्रीवियस थ्योरम. इंटीग्रल ऑफ फाई इंक्रीजेस टू इंटीग्रल ऑफ फाई, इंटीग्रल ऑफ साइन आल्सो इंक्रीजेस टू इंटीग्रल ऑफ फाई. So that means both the limits are same in that case. But here this f is not integrable, and still the limit of the integrals are same. Okay, so then limit of integral of phi n is same as limit of integral of psi n. These limits possibly may be infinite limits, okay? Infinite भी हो सकते हैं. So उसको लिखने की जरूरत नहीं, because we are dealing here with extended real number system. इसने mention किया है, but that's not necessary here. Proof. So first, for each fixed m, we have for each fixed m, for each fixed m, so we have phi m meet psi n. Meet means the minimum value of these two. Okay, minimum value of these two. What's the limit of psi n? It increases to f. Okay, so this phi m is fixed. Okay, m is fixed. So this limit, this so it increases to phi m meet f almost everywhere, because psi n increases to f almost everywhere. आपने phi m को fix कर दिया. Okay, it's fixed. But this it's given that this phi m it increases to f. ये तो given है आपके पास है ना, phi m, और you can say phi n. अगर आपको m के साथ confusion हो रहा है क्योंकि m आपने यहाँ fix कर दिया है, this phi n it increases to f. It increases to f. आपके पास increasing sequence है और इसका लिमिट क्या है, f. आप मुझे बताइए ये जो f होगा, is it lesser equal to phi n lesser equal to f or phi n greater or equal to f? आपके पास इंक्रीजिंग सीक्वेंस है, इंक्रीज हो रही है और इसका लिमिट कुछ है आगे. यस, phi n greater or equal to f. कोई और? देखिए मैं फिर से आपके पास सीक्वेंस है, ये इंक्रीज हो रही है, ठीक है, और इसका लिमिट f है. अब मुझे बताइए ये जो सीक्वेंस की जो टर्म्स है, और दिस टर्म इज लेसर इक्वल टू f और ग्रेटर इक्वल टू f. सीक्वेंस इंक्रीज हो रही है क्या? इंक्रीजिंग सीक्वेंस है, इंक्रीजिंग सीक्वेंस है, नोट इंक्रीजिंग सीक्वेंस. सीक्वेंस बढ़ रही है और आगे इसका कोई लिमिट है. अब वो लिमिट क्या है? वो ये जो सीक्वेंस की टर्म्स है वो लिमिट उनसे बड़ा है या उनसे छोटा, क्या है? रोल नंबर 36. यस
सर, phi n less or equal to f.
Okay, phi n lesser equal to f. That's right. It's lesser equal to f actually. It's lesser equal to f. You can also prove this. This phi n is lesser equal to f. Phi n of x आपको check करना है. Phi n of x. That you can do actually. If you fix any m like this, if you fix any m, phi m of x, it's lesser equal to phi k of x for all m lesser equal to k. If you choose any k greater or equal to m, this phi m is lesser equal to phi k. Now this k is not fixed. K is any number greater or equal to m, but this m is fixed. Now you can apply the limit on this side. The limit is equal to m. अगर ना आपको इसको प्रूव करना है, हाउ दिस 5 इज लेस और इक्वल टू f for each m fixed. So this phi m is less or equal to f. Then what is the meet of phi m and f? Meet means the minimum value of these two. It's phi m, okay? It's phi m. It's phi. So therefore we have phi m meets psi n. It increases to phi m almost everywhere. Now let's apply the above theorem. Now they are now step functions. Everything is step function here. This implies integral of, but this m is fixed, okay? Here it increases to integral of phi m for each m fixed, okay? For each m fixed, or you can write here this limit holds for all m greater or equal to 1. Now again we have the meet of phi m and psi n. Meet of phi m and psi n. Meet of phi m and psi n. Okay, it's less or equal to psi n. Always less or equal to both. Meet of any two functions is less or equal to both the functions because you are taking the minimum. Minimum of phi and psi is less or equal to both phi as well as psi. This is also true for each fixed m. For each fixed m, or for each mn, it's also true for each mn. For all n and m. Now let's apply the theorem first, the monotonicity theorem. If we have two step functions phi and psi, phi less or equal to psi, then integral of phi less or equal to integral of psi. Here these two functions, they are step functions, so we can apply that here. But before applying that, we write this equation here. This limit phi m, it's equal to the limit of phi m. जो है ना ऊपर हमने लिखा this phi m, it's equal to limit of this. Okay, so इसका आप याद रखिए. phi m meet, it's not join here, it's meet. You write meet here, okay? Phi m meet, not join, minimum. So now let's see this phi m, which you have seen that integral of phi m, this is equal to limit n approach to infinity integral of phi m meet psi n, but phi m meet psi n is less or equal to what? It's less or equal to psi n. It's less or so its integral is also less or equal to psi n. It's limit n approach to infinity integral of psi n. So this is true for all m greater or equal to 1. So let's apply the limit on this side. This means the limit m approach to infinity or limit n approach to infinity, that's one and the same thing. Limit n approach to infinity integral of phi n is less or equal to limit n approach to infinity integral of psi n. So now by symmetry of phi n and psi n, you can see that limit of psi n is less or equal to limit of integral of phi n. By symmetry argument, you can verify that also. Okay, by symmetry, you can see this limit n approach to infinity, integral of psi n, integral of psi n is less or equal to limit n approach to infinity, integral of phi n. So therefore combining these two inequalities, limit n approach to infinity, integral of psi n is same as limit n approach to infinity, integral of phi n. So this theorem is very important. F is a limit. या आगे जब आप इंटीग्रेशन थ्योरी पढ़ोगे, लिबिक इंटीग्रेशन थ्योरी, वहाँ पर इसका यूज होगा.